All right, so next we're going to create our spines now on our stem. Let's start just by putting down a scatter SOP. Connect that to our sweep. I'm just going to leave it at the default 1000 points here. Let's add some normals to this. So if we put down a normal SOP just before our scatter, so we're adding point normals here to our sweep. These will then be inherited by the scatter, so we've now got normals coming off our surface. Now I want to randomize these just a little bit more, so I'm going to put down an attribute randomize here. Let's set our attribute to be normal. Let's add to our current normal direction, so we're going to add this value on. I'm going to set the distribution to be inside sphere, so we get a random direction inside a sphere. And let's just adjust this a little bit more. Now you can see as I increase this, because we're adding this to our vector, adding this to our normal, we're actually increasing the length. We don't really want to do that with normals. We want to keep these to be a unit length of 1, as I mentioned before. So we're going to normalize our normals. Sounds a bit weird, but it's going to fix this for us. And we can do this with just a point wrangle here. Let's just call this normalize n. And we're going to say attribute normal equals normalize attribute n. So now everything's fixed. And if we were to attribute randomize this, you can see we're just adjusting our direction now and fixing the length in the next step. So I'm just going to add a little bit here, probably about 0.6, I think, just to add a bit more variation to our directions here. I'm actually going to use our normals nut up to align our splines for this model, because there's a nice technique where we can actually just mix between two normal directions to kind of control the splines for our animation. So I'm also going to now create an up vector, and I think I'm just going to do it on the x-axis. Since our spline's unrolling down the y, the x is quite a nice sort of axis to have our up vector on. So let's just put down an attribute create. There's lots of ways you can sort of create attributes. You can use a wrangle, you can use attribute randomize, attribute create, whichever works for you. I'm just going to go here and use this for now. So let's call this up. So vector type, and for the value I'm going to set this to be 1 in our x. So that's going to create, that's setting our up vector just to be along the x-axis. Cool, okay. So the next thing is we've actually scattered our points on moving geometry, which isn't ideal because you can see, if we play through this now, that we get jumping points. Now unfortunately we can't scatter this on the geometry before it's animated, because we are animating our spline up here with our rig wrangle. Then we're generating our sweep. So there's not a version of our sweep without any animation on. But we can use attribute interpolate to sort of stick these to our moving mesh. So let's just put down interpolate, attribute interpolate. And this is going to allow us to stick our points to our geometry based on their source prim and their source prim UV. Now the source prim is just the primitive number, and the source prim UV is kind of like the inherent UV coordinates of our mesh. The mesh looks a bit messy here because we've randomized our normals, but it doesn't matter. We're not going to be using that particularly for the end. Let's look at this next. If we come to our scatter, this is currently moving. Let's time shift our whole geometry here. I'm going to delete our expression here by pressing Control Shift. I'm going to set this to somewhere near the end, so probably about 120, I think. So we've now fixed our geometry to be static. We can scatter our points on this, so this is not changing anymore. And let's just feed this into the first little port here of attribute interpolate, and we're going to feed our moving geometry into the second. If we view this now, it's going to error because we need our source prim and our source prim UV. Now we can generate this, in fact, on our scatter. If we come back up here to our output attributes, we can click on this to enable source prim UV. And that's all you need. So now we have nice stuck points moving down the length of our curve. So it's a pretty useful technique. You do need to have, I think you need to have consistent geometry that's not changing over time. I mean, not changing point count, but something like this works great. So it's going to allow us to keep this nice stuck, scattered motion. Okay, so let's next create the spines for our geometry. I'm going to put down a line, good old line. I'm going to set this to be 1 on our Z because we want this to be facing along our normal. For our length, I think about 25% of our length of our stem, 25, maybe 24. Let's be specific. Okay, so we've got that. Let's give it 4 points here. And I'm just going to edit this a little bit to create a little bit of an arc rising up like this. So I'm going to tap S to select, press 2 to make sure I'm in point mode. I'm just going to select this one, tap T just to move this up a little bit. S to select again, just grab this one. Again, T just to move this up a little bit more. I think something like that just to give it a bit of a curve. So let's resample this. We are going to use maximum segments. Let's just go for 10 for now. Let's go for subdivision curves so it's nice and smooth. And let's also enable our curve U attribute again. So we've got our curve U running down the length of our spline. I'm going to now add a sweep just to create geometry from this. And as always, I'm just going to use a round tube to create this. Let's bring the sweep radius down a bit, probably about 0.01. Turn off our point displays. Let's also come to our scale along curve. Just make sure we're going to use that to sort of define the shape. So let's drag down our first point here. Got both selected, so it's actually made 2. So we're going to have a narrow end, narrow start. I'm going to bring up this point somewhere around here, and maybe another point around here, just to give it this kind of like tapered or flaring arrow pointing along our curve like that. Let's select all of these and just smooth them out by setting them to be monotone cubic. I'll just rearrange that a little bit. Shift that one up there, a bit like that. I think really also might just add a bit more geometry to try and capture this shape a bit better. So let's go back to the resample. Let's bring it up to maybe 20 points. It's really just about capturing the end here. It's kind of annoying because we don't need as much geometry back here potentially. In fact, maybe just to save on our polygon count, let's put down a refine after our resample. So refine can do almost like the opposite thing of a resample. It's almost like a poly reduce in some respects. So if we turn this off, we can come to unrefine. Oh, in fact, we do need to have this on. Let's use our tolerance here, and actually let's turn on first U, second U, and just set this to be the entire spline for now. So with this enabled, if we select it, you can see we can actually use this tolerance to sort of reduce the points in our spline to make it simpler. It's quite a useful function, this, but it is a little bit sensitive. You can see with even just the tiniest numbers in here, if I go to the very smallest, it's very hard to get anywhere. Not too bad there, maybe the very, very small amount like 0.0004, you can start to get that sort of curve in there. But let's just refine this further just by pulling down our U and V. So by doing this, we're actually only unrefining part of the curve. So if I go to 0 and 0, it's not refining anything. And as I drag this up, you might see there's a little blue dot there, and it's slowly reducing our points there. So I think I'm going to bring it to about this, somewhere around this line. It's going to give us a bit better geometry. Not better, but we're just saving some more polys here. So we've now got 14 points instead of 20. So when we clone this over our mesh, we're using less geometry. Okay, so let's put down a sphere. I want to add a little sort of end to our spine here. going to drop down this sphere. I'm going to make it a polygon. I'll make this way smaller. 0.02. No, maybe smaller than that still. How big's this? Maybe 0.05. I think sort of around that size will work. I'm just going to copy this onto the end of our spline here. We did this before. We can use copy to points. So if we do change our spline later, this will stick. Let's drag in our sphere to the first port, and let's drag our spline to the second. This is actually copying it to every single point, but we can use our target points here to specify this. Now, instead of using a group, we can also use the curve view attribute we set up earlier. If I just enable our curve view here, got it set as a marker so we can see the values 0 at the start and of course 1 at the end. So if we were to come here to our copy to points, let's just say attribute curve u equals 1. It's basically going to create like a group on the fly. So we can use attributes like this and expressions to kind of create these intermediate groups that will then work for us. So there we go. There's our spline. You can see if I set this to 0, it will only evaluate to true where curve u equals 0 on the curve. So it's a nice little function. You can use this in a lot of places as well, like any SOP. Let's put in a delete, for example. Under group, we could say delete all points. And then we're going to delete based on curve u. So again, you just put your expression in there. Let's say if it's less than 0.5, I'm going to turn off our template. You can see we've now deleted every point based on our curve u if it's less than 0.5. So I use this a lot. This is such a cool feature. It's almost hidden in Houdini, but yeah, really nice. So I'm going to delete that one. This is our sphere copied to the end of our line now, and then let's just combine these together with a merge. I might just make the sphere a little bit bigger, 0.06, something like that. Okay, so let's move this over. Let's copy onto our points now. We're going to use copy to points. Drag our spline into the first, drag our points into the second. Let's enable pack and instance, so they're instances. And this is what we have so far. Just for a bit of variety, let's also color these just for visualization. Just for a bit of fun. Let's put in a color SOP. I'm going to color based on ramp from attribute, and let's just color based on our original curve view of our spline. And for this, let's go for infrared. I like infrared. Okay, so there we go so far. This is now it unfolding. There's a bit more work to do. We want to sort of randomize our scale and our orientation, but it's coming along nicely.